Welcome to this video on mechanical testing. During this film, we will cover the definition, some of the properties that can be looked at, as well as some real experiments completed in the engineering labs. So what is mechanical testing? Mechanical testing reveals the properties of a material when force is applied dynamically or statically. As well as this, testing shows whether a material or part is suitable for its intended application by measuring certain properties. These properties include tensile strength, elongation, hardness, compressive strength, fatigue limit, fracture toughness, and many more. In this video, we'll be looking at compressive strength and tensile strength. For this, we'll be using concrete. Concrete is made up of cement, a substance that acts as a binder which sets, hardens and adheres to other materials. The other material is called aggregate, often sand, gravel, crushed stone and other mined materials. This serves as reinforcement to add strength to the overall composite material. Water is added, which reacts with the cement to form a slurry which can be poured into moulds, forming the shapes desired. This hardens over a period of roughly 28 days until this curing process is complete and the moulds can be removed. Now the concrete is ready, we can begin testing. Our first test is one for compressive strength. For this, concrete cubes are loaded into a hydraulic testing machine which can measure the force used during the experiment. These are tested to failure, which is called destructive testing, which means we can't use this sample again. Even with the naked eye, we can see where the cube has failed. The next test is one for tensile strength. This specific one is called the split test. Concrete cylinders are loaded into a rig such as this. During the test, the rig is compressed with two 10mm wide wood beams providing contact with the sample. What this does is impart a vertical compressive stress and a horizontal stress, which means the cylinder now undergoes a uniform tensile stress longitudinally. This means the cylinder will split down the longitudinal axis, hence the name the split test. The next test is called the flexural test. This is also a test for tensile strength. Equal loads are applied at a distance of 1/3 from both beam supports, which means stress in the bottom edge of the beam increases. The beam flexes or bends and eventually fails. Many of these samples, whether they have been destroyed or not, are removed and kept in storage, ready for later analysis.